Hello again, our most valued student. My name is Confident and welcome to AgroLearnTech's 24-minute lesson. Our lesson today is the lesson on mechanotechnology, and the focus is going to be on power transmissions. In this lesson, we're going to look at the economic factors to be considered when selecting drives. We are going to look at the difference between V-belts as well as wedge belts. We are going to look at individual belts, the V-belts as well as wedge belts, the differences between these belts, the multiple V or wedge belts, the advantages of these belts, the factors to be considered when installing the V or wedge belts, the maintenance of these belts as well as the calculation involving these belts. Now, when we are talking about the V-belts or the wedge belts, we are talking about the belts that sometimes you find being used in pulleys, in gearboxes, and in different areas in the machines. So this is one example here of a V or wedge belt, and this is also another example of a V or a wedge belt. Now, there are some factors that you need to consider when you are selecting the belts that we currently look at. There are some economic factors that you must consider. In other ways, you need to consider the cost involved when selecting these belts. For example, a question in exam came saying, briefly describe 3 economical factors to be considered when installing any transmission drive. The first thing to consider is the initial cost of installing a particular drive. Is it cheap or it is expensive? The maintenance of these drives as well as the working life of a particular drive. As we move on to look at these drives, we're going to look at the differences between the V-belt and the wedge belt. Now, the V-belts are no longer used in new drives but are available as replacement in the old existing drives. So if you look at this V-belt here, we are saying it used to be used but now it is being replaced by the wedge belt. The major difference is that the V-belt here, it is straight, while the wedge belt, as you can see, it have a curve, a wedge on the top. So this is the major difference. They can ask you to sketch these 2 diagrams to show the difference between a V-belt and a wedge belt. Now, where do we use V-belts? We use V-belts to transmit power from a motor or engine to a specific machine or unit such as a fan. The motor or engine is called the driver and the machine or unit is called the driven. So whenever you see a fan rotating, it means there is a motor. In these places, we are talking about big fans, such as the fans that you see in industries, so as to bring in some ventilation in a building, or to cool off a big machine that is producing some heat. So for these fans to be rotating, there is some belts at the back that are connected to these fans or that are connected to the motor. So these belts are called the V-belt. Now, the motor or engine that is causing the belts to move is called the driver, and the machine or unit is the driven. Now, the V-belt consists of the following. They consist of an improved heat and oil resistant cover. In this case, on the diagram, this is the cover that they are talking about. It is oil resistant. Why? Because V-belts operate in areas inside the engines that can be oily. So they need to have a cover that is resistant of oil. Otherwise, the belts themselves will be covered with oil and it affects the lifespan of the belt. A polyester, the V-belt also consists of a polyester nylon or rayon. This is strong and durable as well as flexible. As you can see here, they are talking about that V-belt as a polyester nylon or rayon. A cord to support the cushion. There is a cord to support the cushion. A fiber-loaded base for greater power transmission. There is a fiber-loaded base for greater power transmission. You need to know this diagram as well as label it because it is very important. The next one we're going to look at is a wedge belt. Now, a wedge belt consists of the following: a double cover for extra service and improved heat and oil resistance. In this case here, you can see that they're saying it is ×2. The cover is a double cover for extra resistance to oil and heat. Why? Because it increased the lifespan of the belt. A polyester or nylon cord for extra strength, as well as a fiber-loaded base for greater power transmission. All these are similar to the V-belt. The only difference is that it is a double cover in the wedge belt, while it is a single layer in the wedge belt. Now, these are also this diagram is also important for you to master because it can come in an exam. So you need to know which one to label as well as short differences. Now, the differences between the construction of a V-belt and the wedge belt from the previous diagram, the question here, it says the wedge belt is an improvement on the traditional V-belt. State 4 of these improvements on the wedge belt. The first one is the wedge belt has longer sides. It has got more reinforcement, remember the double layer, a slightly round top surface to improve its stretching ability. Remember, it was kind of curved like this, while the other one was just straight. So this was V, this was wedge. And it says a double cover for improved heat and oil resistance. Remember these differences between the V-belt and the wedge belt. Now, let us look at the multiple V-belts or wedge belts. Multiple, I think you understand the word multiple means many. Now, these multiple V-belts or wedge belts are used for the transmission of power in heavy-duty loads. The multiple means more than one belt is used in the drive. Where do we use these V-belts? These are used in blowers, fans, in compressors, in pumps, in belts, in conveyors, and in presses. That's where you can find the V-belt, and this is an example of a multiple V-belt. Now, the advantages of V-belts or wedge belts is that they can be used over short distances. You can buy V-belts in standard size and keep them ready for immediate replacement. In other words, you can buy them, they are all come in the same size for the particular machine. When it is used or worn out, you can replace with a similar type of belt. The V-belts or wedge belts drives are silent in operation, meaning they don't make a lot of noise. They need very little maintenance. They are able to absorb the shock loads, especially for a vibrating machine, since most of them, these are fans. They operate at low bearing pressures. A number of V-belts running in a multi-groove pulley is suitable for heavy-duty applications. Multi-groove, this is an example of a multi-groove pulley for multiple V-belts. If a V-belt breaks in a multiple V-belt, the machine can still run on the remaining belts. So, for example, if it breaks on this one, there are two that can run so that the job can still continue without any failure of the power. Now, let us look at some misalignments that occurs during the aligning of shafts and pulleys. By misalignment, we'll be saying where the belt is being installed, there is a misalignment in the way the pulley is running in the belt, to an extent that the belt is not running straight, but it is wobbling. The first one that we see as a misalignment, this is the first misalignment in which shafts are not parallel. So whenever they give a diagram like this, remember this diagram means that shafts are not parallel. That is the first misalignment. They can give that diagram, or they can give this diagram, or they can give that diagram. Whenever you see these diagrams, it means shafts are not alignment. The next misalignment that occurs is that pulleys are not aligned. In this case, you can see the pulley was supposed to be in this area, but it is out of line in this area. Then the next, this one now shows where there is alignment. In other words, pulleys are parallel and aligned. This is the proper way whereby the pulley is parallel and it is also aligned to the shaft. The pulley as well as the belt and the shaft are aligned. But look at the previous diagram. Again, there was some misalignment, and also in the diagram here there was some misalignment. Moving on, the tension on a V-belt or a wedge belt. Now remember this diagram because they can bring in an exam to label it. This is a V-belt in here. In this V-belt, as you can see, it goes in like that. There is a motor. With the motor that is causing the rotation, there is the pulley. You have a bolt, the base plate, the space to allow movement of the motor. Don't forget this diagram. Now, factors to consider when installing a V-belt or a wedge belt. If a belt is incorrectly installed, it can cause excessive wear and uneven loads on the drive. The factors are that you must consider whenever you are installing this belt. You must consider the center distances. Aligning shafts and pulleys, that's the second factor. The first one is center distance. The second one is aligning shafts and pulleys to avoid misalignment. Remember, there is an exam question here that you must also remember. It says 4 negative results due to misalignment of shafts and pulleys on a V-belt or a wedge belt. What are the negative effects of those two misalignments that we looked at? Misalignment can result in quick wearing of the belt flanks. That's the first one. The misalignment can result in wearing of the pulleys, in other words, wear and tear of the pulleys. Uneven loads on the bearing, that's what it can cause. It can also cause excessive friction and heat between the belt and the pulley. This is an exam question and I want you to master it for number 2. The other factor to consider when installing this V-belt or wedge belt is the use of idlers on the V-belt and the wedge belt. Now, in regard to idlers, you should never use idlers on V-belts or wedge belts to increase the arc of the contact on the small pulley, such as this one. You are trying to increase the arc of the contact by putting an idler in the wrong space. Here, this is an idler they are talking about, but this particular idler, when you put it from outside so that you can increase the contact on the smaller pulley, it is the wrong way. They are saying you should never use an idler again to increase the tension in the belt by adding pressure on the back of the belt. So if you want the tension to be tight, do not put an idler on the outside. The arc contact on the pulley must be compensated by increasing the number of belts in the drive, as well as using the idler on the inside of the belt. So this is the correct way of using an idler on the inside of the belt. Now, factors to consider when installing the V-belts and the Vbelt and the wedge belt. The next factor is taking up allowance, tension, and the slip on V-belts as well as wedge belts. Slip means unintentional movement between the belt and the pulley. The belt deflection is the amount of movement or slackness in the belt. Now, remember again this diagram. It is very important for you to know the diagram. Now, let us look at the maintenance of V and wedge belts. Adequate maintenance of V-belt or wedge belt is very important to ensure optimal operation and a long trouble-free belt life. Factors to consider on the maintenance of these: it says check for damaged pulley contact surface that can cut or damage the belt. Check the condition of the belt and replace it when it has deteriorated. In other words, when the belt is getting weak, you must replace it. Belts can deteriorate as a result of the following. Now, in this question, be careful of such a question in exam. It says 5 factors that can contribute towards the deterioration of V-belts or wedge belts. The first one is small cracks due to excessive heat or chemical fumes, heat caused by slippage, incorrect tensioning of the belt. Remember, using in the previous diagram, we said if you are going to use the V-belts with an idler on the outside, like this diagram, it is not allowed. That is incorrect use of an idler. That is incorrect tensioning of the belt. Worn out pulleys, fluid contamination that results in the swelling or softening of the belt. Sometimes the belt can have some fluid contamination like an acid, and it can actually damage the structure of the belt. Now, the next part says on the maintenance of wedge belts and V-belts. It says adequate maintenance of V-belts or wedge belts is very important to ensure optimal operation and a long free travel life. Factors to consider are: follow the correct installation procedure, fit guards to ensure that foreign objects like rags, pieces of metal or wood and tools do not make contact with the belt, keep mesh type of guard free from paper, rags, fluff or mud to ensure sufficient air to the drive if necessary. That is, make sure that whenever the belt is in operation and it is covered inside a mesh, that area must allow air to come in and out so that it can cool. Check the belt deflection at regular intervals because belts tends to stretch. Check whipping of the belt during running. This can result in incorrect tensioning. critical vibration frequencies in the system. Store replaced sets of belt kept as spares under cool, well-ventilated conditions to guard against overcure and resultant cracking and premature failure. Do not operate standard belts close to radiators, furnaces, and steam pipes, or inside unventilated guards where they may become overheated. Those are factors that you must consider. Never use, that is on the maintenance again, never use lubrication or belt dressing on V-belts or wedge belts. Slippage may overcome. In other words, never lubricate these belts. The question here says, explain 4 ways in which slip can be prevented in wedge belts. How can you prevent slip? Slippage is not needed in a wedge belt, but you can prevent it by replacing worn pulleys, changing the belt tensioning, getting rid of dust, as well as correcting the drive. Again, moving on, when selecting these wedge belts, there are certain factors that you must consider. So you must carefully consider the important factors: the speed ratio, the design power, the minimal pulley diameter, the center distance, the correction factor, the additional power, the number of belts, the service factor, the belt selection, the pulley pitch diameter, the belt length, and the correct belt power. Now we are going to look at some of these calculations as we continue. The first type of calculation that we're going to consider is what is called speed ratio. Now these are the calculations that we're going to focus on in this topic on power. Mechanotechnology has very minimal calculations and they contribute about 10% of the whole paper. So even if you are weak in calculations, you can still do mechanotechnology and get a distinction because the calculations are very minimal. And the first part where you can find them is in this section of power. The first question is about speed ratio. Now speed ratio is determined by dividing the speed of the faster pulley by the speed of the slower pulley. They will not provide you with this formula in the exam. So you need to master this formula. Know this particular formula. It says speed ratio is speed in RM, which is rotation per minute of the faster pulley, over speed in RM. RM means, or RMIN is rotation per minute on the slower pulley. For example, it says a 105 kilowatt electrical motor runs at 900 RM, drives by means of a wedge belt hammer at a speed of 500 RM. Before you consider reading everything, the most important things are those that I've underlined. Look at the first one is 900 rotation per minute and the other one is 570 rotation per minute. Surely, if they say calculate the speed ratio, so you say simple speed ratio using that formula. Remember, you got the formula. It says faster pulley, and you can see the faster pulley is 900 over the slower pulley is 570. And what are you going to get as your answer? You are going to get 1,58 is to 1. This is how you write it. That particular answer that you get on the calculator, you write it first and then you say is to 1. Remember, it's 1,58. That's the answer on the calculator. And then remember, ratio must have is to. But is to what? Is to 1. Because when you cancel there, you'll get 1,58. And at the bottom, you'll get a 1. So it's 1,58 is to 1. Now, the next part that we're going to look at is the service factor. Now, in the service factor, you're going to distinguish between soft and heavy start, the types of driving machines, and then the hours per day that the machine will operate. Now, the purpose of the service factor, very important, is to increase the size of the belt in order to suit the increasing demand of duty. Remember that. Now, when we're talking about service factor, please note, this is also an important calculation. It's not a calculation as such, but it's very important for you to understand how you find it. Again, we'll consider reading here. It says a 105 kilowatt electrical motor which runs at 900 per minute drives by means of a wedge belt hammer at a speed of 570. This is a heavy duty. Distinguish between soft and heavy. This is a heavy duty, I underline that word, operation, and perform at 9-hour duty per day. a centrifugal clutch is used as soft start. Find the service factor for this drive. Now in here, you're going to come to a diagram or to a table that they're going to give in an exam. Now they said heavy duty. You look at the classes. There is class 1, class 2, class 3, class 4. In our question, they said heavy duty. So you come and look under heavy duty, which is class 3. They also said 9 hours per day and soft start. So you're going to look at soft start and you're going to look at 9 hours per day. This is under 10 hours. So 9 hours per day is under here. So if you come here and you look at heavy duty, there is 1,2. So the service factor here is equal to 1,2. That's how you just find the service factor. As we move on again, after finding the service factor, the next thing to do is to calculate the design power. There is a formula to calculate the design power, and I'm going to write it down. So when you calculate the formula for calculating design power is equal to power of the electrical motor times service factor. Now if again we go back to our question, it says 105 kilowatt electrical motor, so that is the power of the electrical motor. So that's why we use 105 kilowatt. Runs at that. You can read everything, but the important thing here was the 105 kilowatt. So you take that 105, you multiply by the service factor that we got from the previous question, because it will be a follow-up question. You multiply by 1,2, and the answer you're going to get is 126 kilowatt. It still says design power, and power is measured in watts or kilowatts. If you move on, now we are looking at the minimum pulley diameter, which is measured in millimeters. Diameter is a distance. It says 105 kilowatt, same question again, continuing. 105 kilowatt electrical motor which runs at 900 rotation per minute. You can read again the whole question, but whenever you are looking at the minimum pulley diameter, look what is important. It is the speed of the faster pulley. Speed of the faster pulley. In this case, it is 900. So we're going to look at the number that is nearer to 900. In this case, it is 960, as well as then the design power. But remember, in the previous question, we said the design power after calculation it was 126. So here, design power is 126. You are going to look at the number close to 126, which is 130. Now, when you go down here and you come with 960, you are going to find that the minimum pulley diameter is 300 millimeters. So that is the minimal pulley diameter. Moving on, in this question now, we are going to look at the pulley pitch diameter, center distances, belt length, and the correction factor. It says design a wedge belt drive in terms of the belt section and the number of belts required for a 50 kilowatt electric motor which runs at 1250 rotation per minute to a uniform loaded belt conveyor at 700 rotation per minute. It is light duty. The center distance approximately is 2100 and the duty is 12 hours per day. Find the pulley pitch diameter. Now when you are looking at this, remember again, it's talking about speed ratios. In this diagram, you can find it in the textbook. So the speed ratios are here, and whenever you look at the speed ratio, in this case it is 1,78. If you go down here, it still does not have 1,78, but if you go to the next one, on the 16N PSP wedge belt, you're going to find it in this particular range. And then when you go across the number nearest to 2000, the most important one, they said center distance is 2100. So with that 2100, what you need to know, if you go backwards, you're going to see that the driver, that is the pitch pulley diameters, the driver will be 200. Driver is 200 millimeters, and then the driven, which is the smaller one, is equal to 355 millimeters, as well as if you look at this particular center distance, the number that you're going to have here is the belt length. So the belt length here is equal to 5070. in this particular belt length, remember the question also says find the belt length, find the center distance, and then after that says find the correction factor, and the correction factor is just above, which is 105 as the correction factor. Now moving on, the basic power belt, it implies that no power losses have been taken into account and that the belt runs under ideal conditions. You need to know the definitions of the basic power belt. You also need to know the definition of a corrected power per belt. It refers to the power needed per belt after power losses are determined. The formula for these, you are going to find it in your Mechanotechnology. They will give you these formulas. Is that formula for the basic for the corrected power belt. Last but not least, the last question that they can ask you is the number of belts. For example, in the question below it says a blower rotating at a speed of 700 rotation per minute is driven by a 30 kilowatt electric motor which rotates at 1200 rotation per minute. This is a medium duty operation that performs at 11 hours duty per day. The type of start used for this drive is soft. Calculate the number of belts. Calculate the number of belts if the corrected power belt is that. Now look at the formula. They will not give you this formula. You need to know this formula by heart. It says number of belts is design power over corrected power belt. But if you still remember design power, I'll call it DP. You say it what? You are multiplying the power of the motor, which is power of the electrical motor, is power of motor. You're multiplying the power of the motor times the service factor. I'll call it SF, which is the service factor. But now you need then to find the service factor. How do you find the service factor? They told us it is a medium duty. There is a table for that. Medium duty operation. It performs 11 hours per day and it is a soft start. So if you go to that diagram of the service factor, if you still remember, they said it is a medium and it performs for 11 hours. If I can lose a pen, it's a medium duty. It performs for 11 hours and 11 hours is between 10 and 16, and then it is soft. So you can see that the service factor is 1,2. It's a soft start. So if I come back to my question, again, it was soft start 11. They say service factor here, it was 1,2. And then the power of the electric motor is 30. Now if you multiply that particular 30 by 1.2, you are getting 36 watts, kilowatt. So now if you are going to find now the design power is 36 kilowatts, and then the number of belts then becomes 36 over, they told us the corrected power is that one, which is 20.98, and the answer that you're going to get on the number of belts is equal to, if you look at it, is 36 divided by 20.98. you are also going to get 1,72. This is the number of belts in this case. So the number of belts needed there is 2 belts, because 1,78, if you round it off, because you can't get 1,78 belts. A belt is like a tangible thing, like a cup. You can't get 1,2 cups, so you round it off, you need 2 cups. So now these are the calculations that you must expect in an exam. Well, it is a 24-minute lesson, but because of the number of calculations and the length of the lesson, it was extended. We are going to continue on the part 2 of power, whereby we are going to look at segmented power belts. But as far as calculations are concerned, please master these calculations. They are the main calculations. They are not difficult. You just need to master a few formulas and then implement them. So we have come to the end of our lesson. Go slowly again to the previous lesson, and we will continue on the topic of power, because it is one of the major topics that carries marks in the exam. There are more other topics that are to follow under the power transmissions. Thank you.